Hi guys, welcome back to Primax Classroom. We're still on the series of the topic stoichiometry. In class 1, we talked about how to calculate relative molecular mass and percentage composition. And in class 2, we talked about how to determine empirical formula and molecular formula. In class 3, I taught you how to balance chemical equation. So by now, you should know how to balance different chemical equations. So in this class 4, we will be talking about mole concepts. When we dealt with balancing chemical equation, I taught you that we're going to have what we call reaction stoichiometry, in which we're going to see the relationship between reactant and product. And I gave you what we call the mole concept. So now we want to look at that mole concept properly. So when we're talking about mole in chemistry, what do we mean? Let me give you the first definition. So get your pen ready and write. A mole is defined as the amount of substance that contains as many elementary particles as there are in 12 grams of carbon-12. You can pause to write. Now, we use carbon-12 as the standard unit in determining mole, because if you say 12 grams divided by 12, you're going to get 1 mole. So a mole is defined as the amount of substance that you can have just like you have in 12 grams of carbon-12. So that is what we call a mole. But do not bother yourself about this definition yet. You're going to understand what that means. Now, in chemistry or in physics or in any form of calculations we do in science, always make sure we have a standard of units. Like now, what is the simplest unit of time? It is second. You know, we can measure time in hour, in minutes, and in second. In chemistry too, the simplest unit you can have is mole. So if I give you mass in gram, I give you volume in cm cube, I give you concentration in mole per dm cube, you can calculate all of those things in mole. So I will be telling you a whole lot of things about the mole concept. So we need to understand some basic things before we go deep into the calculation. So these are some points for you to note. So I already said that mole is the standard unit. So now look at this point. 1 mole of a substance contains what we call the Avogadro's number. So the moment you hear that it is 1 mole, it means that the total number of that thing you have is 6.02 times 10 raised to power 23. Just like if I say you have 1 dozen of something, what is the total number? 12. So the simplest unit we use in chemistry is the mole. And that simplest unit has a total value of 6.02 times 10 raised to power 23. So if I say I have 1 mole of egg, that means the total number of times I have the eggs will be 6.02 times 10 raised to power 23. That value is called the Avogadro's constant. So note, 1 mole of a substance contains the Avogadro's constant. If I say 1 mole of you now, that means how many times will I count you? I will count you 6.02 times 10 raised to power 23. That means that's the total number of times you exist that I can see you. Just like if I say I have 1 dozen of you, that means that you exist 12 times. So if I start counting, I will count 12 of you. So if I now say I have 1 mole of, for example, 1 mole of Na2CO3. So what do you think I mean by this? That means that I have this guy, number of 6.02 times 10 raised to power 23. So the number of times I have this molecule or this compound is 6.02 times 10 raised to power 23. So 1 mole of Na2CO3 contains Avogadro's number. This is called Avogadro's number. So 1 mole of any substance, if I say 1 mole of H2SO4, that means it contains 6.02 times 10 raised to power 23 H2SO4. For example, if I say I have 1 dozen of H2SO4, so what do you think that means? That means I have 12 H2SO4. This concept is going to be needed later, so just get it right. 1 mole of any substance, any, contains what we call the 6.02 times 10 raised to power 23. So note that down. 1 mole of a gas occupies 22.4 dm cube. That is another point you have to note. So every time I talk about 1 mole of a gas, it contains 22.4 DMQ. We're going to be seeing why am I saying all of these things as we move ahead. Just note that down for now. Another thing is that, or you remind yourself, you can ask your friend, what does 1 mole of a gas contain? It contains 22.4 DMQ. What is the 1 mole of a substance? It is equal to 6.02 times 10 raised to power 23. So as a science student, you should just know that for now, or even as a chemistry student. Now, when we go on with our calculations, there are sometimes they will give you pressure, and that pressure might need to be converted. So that's why I want you to note this point that I put here. So 1 atmosphere is equal to 760 millimeter of mercury, which is equal to 760 torr, which is equal to 101325 Pascal, and which is equal to 101325 Newton per meter square. These are units of pressure, so please note them. Then you can convert. Every time you want to do calculation, your temperature must be in Kelvin. So you convert from degrees Celsius to Kelvin. And how do you convert from degrees Celsius? So whenever you are given in degrees Celsius, you will add it to the Kelvin scale, to the 273. So that will give you the Kelvin scale. So whenever you have volume, 1 dm cube of a gas or 1 dm cube of whatever volume it is equal to 1000 cm cube. Please note all of these things. We're going to be using them as we move on. The essence of this class is that I will give you a list of formulas. That is all you need. I'll give you a list of formulas. Note those formulas. We're going to be using them to solve some questions. In this class, I will use those formulas to solve some series of questions with you because I want you to get used to those formulas. Just take your time to practice those questions. Now, when you get used to the formula, in our next class, I will now bring questions that has to do with reactions. Then you will now see how to apply the formula and how to solve the questions. There are some shortcuts we use in stoichiometry to solve questions, but those shortcuts I'm not going to teach you now. At the end of our entire class, when you have had the perfect understanding of the topic, then I'll bring back those questions for you to solve. So, let me give you these formulas one after the other and you write them down. Then I'll give you questions after and you solve. So your ability to solve these questions will now determine if you are ready for the next stage. So let's go on. The first formula states that number of moles is equal to mass over molar mass. As long as you are not a starter of chemistry, this formula cannot be new to you. So anytime a question is given to you that calculates mass, your brain should first think about number of mole is equal to mass over molar mass. Anytime you have that, then the next one says that number of moles is volume at STP. So a question can say determine the volume at STP. So anytime they ask you to determine volume at STP, your brain should go to that second formula. You are going to see how we're going to be applying them one after the other in order to see how it all works. So these formulas are all you need. I promise you that in stoichiometry. If there's any adjustment, I'll let you know later. But most of your questions in exams, you'll be able to solve them if you know all of these formulas. So let's get used to them. The next one says that the number of moles is equal to concentration in mole per dm cube times volume. If the volume is given in cm cube, you divide by 1000. So anytime you are given concentration and volume and you are asked to calculate number of mole, this is the third formula your brain should think of. The fourth one is number of particles over Avogadro's constant. So if they say calculate number of molecules, number of atoms, number of ions, number of elements, number of anything, your brain should go to that formula 4. Number of moles is equal to number of particles over Avogadro's constant. Then the next one says that PV equals nRT. That's called an ideal gas equation. You learn that if you are dealing with kinetic theory. And one of the things we note about that is that it is R. You can see the units of R I have there that used to determine what your pressure will be, what V will be, and what T and other values will be. I will solve a question with you on that so you see how it works. Then the last one is from volumetric analysis. You did titration while you were in secondary school or SS2 or SS3. So you are used to CAV over CBVB. So there are some questions that might require us to do that in order to get concentration. So let's get used to that. So now, based on these formulas, I hope you have written them. take a pause and write those formulas down. Then we want to apply them now. So how do we apply these formulas? Let's look at the questions. So whenever you are given a question in chemistry, immediately, first thing I used to do is that, what am I asked? How do I get there? So the first thing is, let's say a question says that, what is the mass of a substance produced? Which of the formulas will your brain think of if they say, what is the mass of the substance produced? Then that means you're going to think about number of mole is equal to mass over molar mass. The next question is, you already know where you are going. How do you get there? That means I need to know number of mole, and I also need to know molar mass. And that's all. The moment you find a way to get your number of mole and get molar mass, then you'll be able to solve the question. You will appreciate this more when we start solving questions together in the next class. But for now, let's solve all of these questions. So the first question here says that, calculate the number of moles present in each of the following. Now, question 1, 5.3 grams of Na2CO3. So you have to calculate the number of moles of 5.3 grams. What are you given now? Mass. So which formula are we using? Very good. We're using formula 1. So let's see how we solve that. Although in our first class, we looked at the molecular mass of Na2CO3 and we got 106, but let's do it again. So now that you have mass, so you're going to have that number of mole is equal to mass over molar mass. Now, the number of mole is for Na2CO3. So the mass is 5.3 gram all over. So let's look at the molar mass. So the molar mass of Na2CO3 is going to be 2 into 23 plus 12 plus 16 multiplied by 3, or 3 into 16. So if you do this all together, you're going to get 106 gram per mole. So molar mass has a unit of 106 gram per mole. Relative molecular mass has no unit. So now you put that here, 106. And if you divide that, that's going to be 5.3 divided by 106. And that gives us 0.05 mole. So you see, you have gram and you have molar mass. Then you can use the first formula. We're still going to be balancing equation and be solving a whole lot of questions. But for now, let's get used to the formulas. So the second question, which formula do you think we're going to use for the second question? 4.25 times 10 raised to the power 21 atoms of copper. You want to calculate the number of mole of 4.25 times 10 raised to the power 21 atoms of copper. So how do we solve that? Definitely, we're going to be using, that is formula 4. Formula 4 says that number of moles is equal to number of particles over Avogadro's constant. So I said anytime they say number of atoms, number of molecules, number of ion, you are using formula 4. So let's solve that in the next case. So number of mole is going to be number of atoms, which is number of particles, over Avogadro's constant. And the number of atoms is 4.25 times 10 raised to the power 21 over 6.02 times 10 raised to the power 23. So if you do that right, so let's calculate. That's going to be 4.25 divided by 6.02. And that's 0.7. So that's 0.70598 times 10 raised to the power 21 minus 23. So when 23 comes up, it takes minus. So that's what we have there. So this is going to be 21, that's 2, so that's 3. So that's 7.05 times 10 raised to the power minus 3. Yeah, minus 3. So that's what we have. So the unit is mole. So that's the answer for the next question. So how do we solve question 3? Which formula? 200 cm cube of 0.025 mole per dm. These questions are gotten from LAMLAD, so you can get LAMLAD textbook to practice a whole lot of questions. And if there's anyone you can solve, you should let me know. I will help you solve them. So number 3, 200 cm cube of 0.025 mole per dm cube HCl solution. So now, which formula are we going to use? You are given concentration and you are given volume. So which formula? So that means we're using formula 3. Formula 3 says that number of mole is equal to concentration times volume. If the volume is given in cm cube, then you divide by 1000. So now the concentration is 0.025 multiplied by 200 divided by 1000. So this and this will go. So 2 here 1, 2 here 5. So 5, this is the same thing as saying 25, 1, 2, 3. 25 times 10 raised per minus 3 all over 5. So 5 here 1, 5 here 5. So this is the same thing as saying 5 times 10 raised per minus 3 mole. So that's the answer. So you can keep solving it that way. So the next question says that 16 dm cube of hydrogen gas at STP. Whenever you hear volume at STP, which formula are you going to use? So you're using formula 2. You can see, just know whenever your question gives you something, you will know where you are going. The moment you know that, in the next class, I'll be showing you how to now balance equation, like you use the chemical reaction to determine these things, while you still apply these same formulas, and you see that you'll be able to solve virtually all the questions. Just take your time and get along with me. So now, in the next one, we have 16 dm cube of hydrogen gas. And what's the formula? Number of mole is equal to volume at STP all over molar volume. So now you're given in dm cube, so that will be 16 over 22.4, and that is going to be 16 divided by 22.4, and that's 0.7142 mole. So the answer is 0.7142 mole. So the last one, which is now very, very important. I told you something at the beginning. The last one says that 200 cm cube. So if you're a learner, you can list it out. V is equal to 250 cm cube of an ideal gas exerting a pressure. Now you can hear the word ideal gas. That means we're going to be applying ideal gas equation. So you have a pressure of 720 millimeter of mercury at a temperature of 37 degrees C. I told you something when we were starting, that the most important thing about this equation, whenever you want to use PV equals nRT, the most important thing is know the units of R. When you know the units of R, that's what will determine the units of P, V, and T, and N. Because if you don't know the units of R, most students used to feel, this formula is very simple. So immediately they see question, they rush into it, they slot in the values, they get an answer, and that answer is mostly always in the options. And most people will feel like it's very simple and they have gotten it right. They might be wrong. So now let's see how they might be wrong. So if you're given R to be equal to 0.0821 atmosphere dm cube per mole per Kelvin, that's the units of R. So this means that the pressure must be in atmosphere, the volume must be in decimeter cube, the number of mole must be in mole, then temperature must be in Kelvin. So whatever you are supplied, you must convert them before you use it in this equation. So you might have gotten it wrong. So let's see how to do that. How do we convert pressure from millimeter of mercury to atmosphere? So you see why the first statement I said is important. So 1 atmosphere will give us 760 millimeter of mercury. So how many atmosphere will I get from 720 millimeter of mercury? So you can just cross multiply. So your X atmosphere is going to be 720 divided by 760, and that will give you 720 divided by 760, and that's 0.97947 0.9474 atmosphere. So that's what we have. So our pressure is now, let me write it here. Pressure is now 0.9474 atmosphere. So now we have converted 720 millimeter of mercury is the same thing as this. So let's convert volume. Remember I said 1 dm cube is equal to 1000 cm cube. So how many dmq will I get from 250 cmq? Shey you get? So you cross multiply. So your x in dmq is going to be, that would be 250. All you just need to do is divide by 1000 though, but let's assume, so 1 2, so that would be 0.25 dmq. So now the units for v, so v as we converted, that's 0.25 decimeter cube. So we have converted V, we have converted P. So let's convert temperature. So temperature in Kelvin is going to be degrees Celsius plus 273, and that's going to be 37 plus 273, and that's going to give us 310 Kelvin. So the temperature value now is 310 Kelvin. So now let's solve for our distance. So you can always take a pause to write. So now we have that PV is equal to nRT. So N is going to be PV over RT. And my P is 0.9474 multiplied by V is 0.25 all over. So all over our R 0.0821 multiplied by T 310. So now let's solve for N now. So that would be 310 0.0821 multiplied by 310 equals 25. So this is equal to 25.451. Then 0.9, 0.9470, 0.9474 multiplied by 0.25 equals 0.23685, blah blah blah. So let's divide that now. So you divide that by 25.451, and that's, so that gives us 0.00931, 0.00931 mole. Or you simply write that in standard form. So you go 1 2 3, so that can be 9.31 times 10 raised to the power minus 3 mole. So that is that about that. So looking at these questions, note one thing: anytime you are asked to solve for something in stoichiometry, just think about that thing. Determine the volume of, so think about which of the formula to use and how do I get there. I will explain this better again in the next class. Then when I'm through with all of the examples and questions, so please practice this, get used to the formula, especially before the next class, because we're going to be needing those formulas in the next class. I'll just ask you to tell me those formulas and we'll start applying them to solve questions. So what we want to do in the next class is to solve questions that has to do with reaction. So if this is your first time on this channel, if you're here to subscribe, please subscribe. And to those of you that have subscribed, we really want to say thank you, because we can see that the subscription is actually increasing in number. So thank you for taking your time out to watch the video. And if you find the video helpful, please, you can help share with others if you find it helpful, please. And we love you. We'll see you in the next class.